Lately I've been building a lot of Tesla coils, and I came up with a unique understanding of all this. And it conflicts with a lot of people in their understanding of things. So let's go into this a little bit. We're just going to be dealing with the DC Tesla coil at this point. We're going to take a ZVS driver, and we're going to run it right here into our number one coil, and it's going to create a frequency. The turning on and off of the MOSFET is going to create the frequency. So, we put the frequency in here, we put 10 volts in there, which means you put about 2 amps in there, and then we get radiant energy that comes out of here, and it goes like this. You may get a little breakout here. Generally in my ZVS lately, I don't get any breakout, and the reason for that is I put a rod right down the center here. Now, it changes the understanding of how this Tesla coil actually works. So let's get into this a little bit. We're going to take a top-down view. So this is the top of my Tesla coil. This would be the rod that I place in the center of it. Now, what am I looking at? Out here, I'm getting a magnetic field. Then, it goes out as my dielectric field. So it radiates energy out to turn on a light bulb out here. That's fairly easy. That's the normal way a Tesla coil works. But let's go into it a little further. What do people not know about this? This is what the understanding is. On the inside, when I do this, I'm also creating a dielectric field. You see, it doesn't just work on the outside. It pushes it inside. So this right here must eventually turn into a magnetic field if we try to flip it and build another Tesla coil. But right now, it's only in the dielectric form. So what am I going to get? I'm going to get heavy RF in this. So, let's do this. We know the light bulb works. How do I know which field that I'm in? You see, I built a bipolar Tesla coil here, and I put my primary here, my secondary here. When I took this right here, and I simply ran the rod down the center, now I connected that rod right here. What should happen if I'm right? Well, I should now go from a dielectric field back into a magnetic field. Then I would have magnetic energy that comes out of here, or I like to call it hot energy. What happened in the testing of that? It did exactly that. Therefore, I know this right here is my dielectric field, but I created a secondary dielectric field that we don't usually use, goes into the rod, goes to here, then when I want to convert, I simply put it back in here and it converts it out here. Would it work if I used a standard Tesla coil instead of a bipolar Tesla coil? Sure. In order to verify correctly, I did the same test with a regular Tesla coil, and it turns it on and oscillates it properly, and I have a magnetic field right here. That's the understanding of Steinmetz in this. Now, you get into transverse and longitudinal waves. Here's where it gets interesting, because a lot of people go from one to the next. But there's an interesting understanding that works here. Let me just clear this off. As I create my Tesla coil, I am going to put out a longitudinal wave on here. That means that out here is my transverse. Now, as we see the rod down the center, what does that mean as well? I have now created a transverse on the inside as well. Seems interesting, right? It shouldn't be that hard to figure out. We know where the forms are. Now, here's one of the misnomers that people have when they deal with this. And it's kind of hard because everybody looks at their oscilloscope and sees the same thing. So let me show you. We see the wave pattern that looks like this, right? You go, well, okay, we know what that is, right? That's a sine wave. That must be how it flows. Well, it's not. And here's why. This looks great. That's horrifyingly bad because it's wrong. You see, there's a different understanding here as well. This right here does not flow like this. It'll actually flow like this. You see, it goes around it. That's pretty simple to understand. And based on the height that is away from it, like that, now you get your value. Now, why would that make any sense? It doesn't sound like it makes sense. We always see the waveform just like this. We never see it rotating anywhere. So how does that even make sense? Well, because number one, when it goes like this, you saw it, it's in 2D. There's no way that it functions. It just doesn't work. We put it in 3D just like this, we know that it works. When we go to mimic AC and DC fields, now we're going to understand why. DC, everybody draws it like this. That's PWM, that's a pulse wave, right? Now, we do our sine wave like this. What are we missing? What's wrong here? Everything's in 2 dimensions. The right way to draw this right here is this. You see, you say DC's on all the time. There it is. Here's your main line right here. DC is on all the time. When we pulse it, we pulse down. We don't pulse up. You see, that's a misnomer. We pulse down. Why? Because we're pinching. If this is the wire, I need to pinch down on this wire to take my dielectric field and pinch it into my magnetic field, which is here, and then I create the pulse. You see, sometimes we get lost in when it goes on and when it goes off, so it makes it hard to understand. But it's not very hard to understand when you say Steinmetz already told you that right here on the outside is your dielectric, inside is your magnetic. That seems pretty simple to me, so we understand that. Now, in order to make this flow on our AC wave or sine wave, in your Tesla coil, you have to do this and this. Now you'll get giant sparks coming out of it. What did I just do? Well, I mimicked it, but right here, that's when my sparks shoot out. Let's look at this in a little different way. We want to look at transverse and longitudinal. We say we take a drop, and we're going to drop this right into a pond, right? So you get something that looks like this, goes down, littler as you go out, and you say, okay, that's longitudinal, right? Okay, what is that actually? There's your Tesla coil ring, right there. I have no problems with saying it's longitudinal. That's your Tesla coil ring going out. Starts big, gets small to the end, just like your Tesla coil ring. Not hard to understand. You see, this part, the transverse wave, is a little harder to understand. Why? Because this looks great, okay? Little lines, looks great. Some people draw it like this. Not really making a lot of sense when they do this, because as soon as you get out of 2D and go into 3D, this whole thing goes bad. All of it. You see, I take a simple sphere. As soon as I put geometry into your stuff and change it, now everything changes. You see, this is where Scalar comes in. 3 dimensions. We live in a nature with dimension. Here's our orange. We know it's in 3 dimensions. As I go out, I'm going to get a magnetic field. I get a dielectric, but a dielectric stops at my next magnetic field. And this is where people have trouble with this. And it continues like this. They said, no. Steinmetz said, like that. That's not really what's going on here. You see, it's got to stop every time and build on the inside and outside. Now, you only know this if you do the testing on it. When you don't do the testing on it, you're going to be completely oblivious and swear up and down this is what it is. But when you do the testing on it, you're going to find that it stops and breaks every time. It's a difference between 3 dimensions and 2 dimensions. In 2 dimensions, this looks great. In 3 dimensions, it's horrifying. It doesn't work at all. Not the way that this is. It's just little lines coming out. They're fields. They interact with each other. So, when I say this, I know that the fields go in 2 different directions. Well, this is a representation of that. If on the outside, it's your longitudinal, on the inside as it crosses, that's your transverse. There's probably a lot of people out there saying no, screaming at their TV. That's okay. You don't have to understand it the way I do. But now, if you want to add scalar to that, now you're going to have to understand it the way I do. You see, we want in scalar it's a topographical map. Oh man, I drew that bad. Let me draw that again. Every line represents a different level. There you go. Okay? Every one, the frequency of every one of those lines is different. Now, it could be just by a little bit, but they're different. What's also different? For every one, the temperature is different. You see, this is one of the misunderstandings of a Tesla coil. You think you're not playing with temperature, but you are. And because you are, you change the fields that you're in. When I look at this, I understand it. So I go, okay, I want to create a scalar field out of my Tesla coil. My rod's down the center, right? I'm going to simply, one frequency. different Tesla coil, second frequency. Now, I can take an iron core wrapped with wire and now use it as a multiplier. You see, if you understand you're dealing with temperature and you understand that you're dealing with a topographical situation where every frequency goes out, it's not a problem. So now it makes sense in the transverse form. Again, we're talking about an orange here. We're talking about 3D, a sphere. In the sphere, for every one that comes out, the frequency changes. But we want to multiply them. We have to see it in scalar. We have to understand that temperature plays a difference. Now, how do I know this? You see, I took this rodent coil right here, and I just put the rod down the center of my Tesla coil. I just connect it to one of the clips over here, just random one. What happened? Well, as I put it in there, the energy was full and turned on the light. When I removed the rod from the center of my Tesla coil, this stayed on. You say, well, why would it stay on? You just pulled the power source, right? It shouldn't stay on at all. Well, the temperature on the inside of the rodent coil was not the same temperature as the outside of the rodent coil. You see, I had a temperature differential going on here, therefore the energy stayed in the coil. So, okay, well, it was lower temperature in here, higher temperature in here, but when this temperature right in the center got back to the temperature on the outside, the power shut off. Now, you can only do that in a scalar field. So, was the rod down the center the scalar? Well, not without the rotating fields that this makes. As soon as it goes through here, now I'm pulling a scalar energy inside that coil based on the rotations of both fields. I know it's hard to understand, but all three of these things come into play. All three of them need to be understood in order to understand the test that I do. I'm taking my Tesla coil and I'm changing the way it works. How do I know what I'm getting? So let's take a look at the Tesla coil again. Simple rod. I put it in a tray over here, and I put the rod right here into the tray. This was just filled with mud. What did the mud do? The mud grounded it. So all the volts and amps that were in this at all went right into the mud. They dispersed. What did I get out of the mud? Pure frequency. That right there, when you match it with a plant and you want growth, grow your plants faster. It's also going to impart the frequency on there to change the sex of your plant. That's what happens to it. It's a transmutation. Because the mud was the ground. You see, I didn't create it like I did a second Tesla coil. The second Tesla coil, you could say it's displacement current. And we moved the current. Well, on this, I grounded the current out. When I grounded the current out, I got pure frequency. Now the frequency could be used for something else. You wouldn't understand that unless you did the test and stood there and put your hand on it. You see, the light turns off. So the frequency goes somewhere. It's not grounding out to the ground. You had already grounded it with the mud. Tesla knew this. He knew exactly this. This is why his paper in the hairpin circuit starts talking about things we can't talk about on YouTube. So, if you want me to use the proper verbiage, what am I going to say? I'm going to say, here's my Tesla coil. I am right here creating a transverse wave. Along with out here is a transverse wave. And right here is a longitudinal. Right here. That's the way it works. But I'm also going to tell you, Steinmetz said dielectric, dielectric, and right here is your magnetic. These are the same thing. We're simply changing the dimension of how they work. Now I've converted everything back. You see, I didn't stop at just doing sparklers or making energy out of it. I converted it back to hot energy. I've converted it back to magnetic energy from the rod in my Tesla coil. So from here, I went and created my dielectric, which is high RF. Then I converted it back to magnetic. I've done the test. They work. I've also grounded out the mud. And it does ground out the current and everything else and leaves the frequency by itself. Both things work. One of the things we deal with on this channel is we always want to look at UFOs and how do they work and how does anti-gravity work. Well, if this understanding here between these things boggles your mind, then anti-gravity is going to be worse. You see, in this understanding, I must now take my Tesla coil here with the rod down the center, and I'm going to have to put it in some form of a plate. Let's just say it's got little legs on it like this. Now, this right here has to go to the plate. This plate must saturate. Therefore, it must be grounded. Why? Because if it's not grounded, you can't complete the circuit through here to the ground. In order to saturate this faster, you must have a pull. That's one of the things that has to be understood about this energy. As you put it here and you put it to a light bulb, the light bulb's going to give you half of what you want. The other half comes by putting it into the ground. Now, I don't get half, I get the full amount. That's the same way here. As I bring it in here, I now can saturate this faster. You see, you're not going to understand this until you understand how this works. So, I had a conversation about the Casimir effect in this. So let's take a look at that. Two metal plates. I'm going to fill them with energy. And in the center here, I get a saturated amount of energy from both, which will increase this number. So the amount of energy goes up. That's pretty simple, right? But what happens here, when I put something in here, I am now taking magnetics, forcing it into a dielectric state. I say, well, hold on. Well, that's what your Tesla coil just did. We took our Tesla coil. Sorry, I'm drawing really bad right now. And I now created a dielectric here. But I had a magnetic out here. They're not dissimilar. They're the same thing. The Casimir effect works in the same way. You say, well, this is two plates. This is two plates. This is a round magnetic field. Nathan, it goes like this. And this one stays here. Why are they the same? Well, because you're going based on the structure, not what's going on. You're looking at how you build it versus what it's building. Magnetic field is building. As it builds, forcing energy in here. You see, all I did was change the geometry of it. And it messes people up. Every time I change geometry, it always messes people up. You got to be able to see through that. This is the same thing as this. It gives you that same effect. We are simply looking for dielectric in here in order to create anti-gravity. That's the understanding of it. We switch fields. What messes with everybody's mind is when you have geometry. But we showed in this, the geometry's flawed. So, but when we fix it like this, and we can understand it coming off of this, just like this, now our geometry, when you look at it, makes a lot more sense. How do I know that that's the right geometry? Okay. Let's just take a look at this. So, this geometry, if I built an AC flyback, I now have my barriers, have my windings, and I'm building energy, right? Okay, we understand that. You're building energy. It's going to come out one side, and you're going to get a heavy spark between the two, or a little one. Okay, that's good. But can this also be a Tesla coil? You see, Sean Calderon proved you can take this and also make this into a Tesla coil. Isn't that interesting? A lot of people told him he couldn't, but there's really not much of a difference here. They say, well, why? All the Tesla coil is a bunch of windings like this that put out a field in between each one of them, and as you hit each field layer, you multiply. Well, that's not that hard, okay? But in this, in each field layer, you're multiplying. Magnetic field, one over top the other, over top the other, over top the other. Magnetic field, one over top the other, over top the other, over top the other. We're simply multiplying magnetic fields. That shouldn't be that hard. The energy has to flow around it. Just like that. We have to understand the geometry of this, because putting it in 2D, like this, didn't work. You see, it falls flat on its face as soon as you show it. It doesn't work at all. You now have to understand it differently. You go, okay, that's AC, but what about DC? You showed it in a different way. Okay. Man, this board really doesn't clean up well, I can tell you that. That's bad. DC starts out here on both sides. It pinches. Then it comes back out. This right here each pulse. It's that simple. It is a field that sits on the outside that comes back in to pulse. Every time that you force it into here, you force these two fields together. You take this right here as your magnetic field, this is your dielectric, and you're pinching them together. You're forcing those fields to come together. And as they do, you're getting a heavier amount of energy. Right here, kind of docile. Right here, extreme amount of force. You see, that's DC. It's pretty easy. It all falls in line with everything that we looked at today. This is how the energy is actually flowing. Now, I'm just in here building stuff. So if you want to tell me there's electrons everywhere, I'm not going to stop you from saying that. By all means, write it up the way you think you should. What I am telling you is when you don't take geometry into account, everything fails. And we fail to understand things. Now, one of the things that comes up in some of this is our piezoelectric. Now, fascinating topic. Let's look at Lenz's law too. That's a fascinating one as well. You see, we take a coil. Let's draw it like this. We have our coil here. We take a piezo, put it here. Now, if we are in positive energy, which is our magnetic field, this will not amplify. But if I am in the dielectric, then this doubles. Now, you see, this is a joule thief circuit. When you say piezo buzzer to ultrasound, it's basically a joule thief circuit. As I push the button, it saturates this with energy. And we all know from a joule thief, the energy goes up. Therefore, the coil itself is multiplying in value. We then release the joule thief and we get free flow that goes through it. Now we get it back down to a normal energy field. That's pretty simple. There's not much more there. That's what it's doing. It's a joule thief circuit. And it's just dealing with saturation of a core and non-saturation of a core. Primarily, we don't saturate the core, but you're going to have to stop the flow in order to saturate the core. You pulse it. Now that saturation becomes a point of massive energy. And if you can continue to go, then you'll get more and more energy. Okay. Now, why is it that when I say negative energy, I defeat Lenz's law? You see, it's a dielectric. That's what I'm telling you. It's the dielectric. The actual magnetic field in a coil of wire, magnetic field's in here, but the dielectric field is out here. If I put the dielectric field in here, what happens? As this structure goes and the magnets are here, instead of this force pushing and coming into contact with this, now that's no longer there. It's on the inside. The amount that I have is very small in comparison to the amount that comes out of this. Every over-unity device uses this understanding to defeat Lenz's law. Once you do, now you can take, like we did earlier with the Tesla coils, and convert your energy back. But this also allows you to take that understanding of the piezo in the Joule Thief in order to create saturation inside of this core itself. Now I can take and double the amount coming out of this because the energy still comes in from the magnet. It's just, where is my field? That's it. You're still getting the energy in there, but now I can take a piezo, and now I can double it. You see, you're simply understanding how it works now. Lenz's law can be defeated when you change where your dielectric is. You won't do it unless you do. If you're getting two magnets together, which is a bad idea, you take one magnet, field, guess what? You're not defeating anything. You're not doing anything. You're getting lucky by moving it in different spots and distances. Change your dielectric, change the understanding of it, defeat Lenz's law to go faster and faster and faster and get more energy. The amount of copper still picks up that energy. It's just in a different form than you're used to. You say, okay, you talk about defeating Lenz's law. How do I convert back? Well, we simply create sorry for my bad drawing, a full bridge rectifier. Right there. I'm going to convert it after I put it into a cap bank. That's pretty simple, right? You put it into a cap bank. This is Bendini, right here, Bendini. Now we convert. If you convert again, sorry for the bad drawing, you've now broken symmetry. When you break symmetry, you get back to the energy source that you're used to. Double conversion breaks symmetry. This right here still needs a light on it in order to pull the draw. Remember, this is going to go over to here. It pulls in here like it's pulling to the ground, and it's filling up this capacitor bank in order to do this. That's how you convert that. That's fairly simple. Tesla coil, I don't know why you would convert it back to a Tesla coil other than what I did to create a test to understand it. But you could. You can call it displacement current. I have no problem with that. But I'm telling you, all of these things are all working in conjunction with one another, and they're not that dissimilar. So, when I say this analogy, if we took our sun, and I saw it as a multiple Tesla coil, right? Bunch of Tesla coils. And I told you, here's our planet. Each one of them has a different frequency. So here we go. Here's Earth. This is Venus, Mercury. Each one correlates to each one. You say, okay, now the understanding makes sense. If I took a Tesla coil here, and I wirelessly put a Tesla coil here, and I made them the exact same frequency, all I have to do is make sure it's grounded. And now I can go at a distance with it. Now it goes and transfers between fields. Dielectric comes over here, could turn into a magnetic. You see, that's the understanding here. What do we also get? Scalar. the distance that each planet is at is also the difference in the frequency of each one. That's why it's scalar out there. Distance, frequency. Also tells you the temperature. I don't know, it seems pretty simple to me. We have a unified understanding of it. Why people don't put this together, I don't know. But it's all right there. So when we go to deal with, anti-gravity in Earth, well, if you understand the Earth has different fields, and each one of them has a different frequency, all we have to do is create the opposite of whatever field we're in. Well, what's the problem with that? Here's why you can't find it. Let me just tell you why. The understanding to find this comes in this part here. This right here. Say that's our magnetic field. We have dielectric on the outside. Now this is pushing in. This is pushing out. Just a little bit, but what happens? We are standing here. That's where we are. We're in between the two fields. You see, that's the problem. We're at a point of saturation. Right here. It's saturated. The saturation creates gravity. We can even take it a step further. If we look at each one coming out of here, we can create time dilation out of the same thing. We know it exists. We know we're here. And we know out here in space, it has a different time than what we are here. So if we understand the fields of counteracting each other, one way, one the other, it's not that hard to understand why we have fields that go out like this. Now how do we see this? We have a Van Allen belt that goes out here. It's trapping radiation in between the fields. It stays there. Doesn't dissipate, it stays there. We are trapping it between the fields. Anyway, I hope this makes you guys understand a little bit more what I'm looking at and why I call things the way they are. Is it scalar? Is it longitudinal? Is it transverse? Pick your theory. I wish they'd just come out with a unified one that actually explains it all like I did. But maybe there's more definition that needs to go into it. Okay? If all you told me was it was transverse and the rod down the center, that's all we're doing, I understand. If you told me in Steinmetz that we're creating a dielectric inside and outside and that it'll continue to build that way, I understand. If you told me that it's scalar based on the distance and the understanding of hot and cold and how that works. You see, I guess I didn't explain this part here. As your frequency goes up, your temperature goes down. When your frequency goes down, your temperature goes up. Why? Because you're putting more magnetics in when your frequency goes down, but when your frequency goes up, you're having less. Well, that's pretty interesting, isn't it? It kind of sounds like our scalar, right? When we have different levels of it, we have different levels of frequency, and as we get taller, it gets colder, but as we get closer down, it gets hotter. Well, that explains the magnetic versus our dielectric field. It's a pretty easy understanding. So, all of this works in conjunction the exact way it's supposed to. Please do not get lost on your oscilloscope and try to say, oh man, but it shows up on my oscilloscope this way. Well, I'm telling you right now, your oscilloscope's wrong, and the people out there that make them should fix them, because then we'd all have the best understanding there is. 3D oscilloscopes is the way to go. get one, figure it out, put it in the right way. But it's the absolute answer, because then people stop being confused. I get sick of seeing this when I look at this and I know where the energy flow goes. But then I get people that just go, yeah, but then, oh, come on. It looks like this on my oscilloscope. Well, as soon as you turn it that way, your oscilloscope looks like junk, because it doesn't work in nature. Anyway, hopefully you guys understand this. Hopefully I explained it well enough. I may have to go over it again, but hopefully you guys get a better understanding. So that's what I have to say today, and hopefully everybody's good with that. All right, have a great day, guys. Thank you. Before we get out of here, I just want to let you guys know that I offer memberships on my channel now. It's a really cool thing. I do behind the scenes stuff. I give you more information. I also put things out early on it. All of my Fringe Think Tank Star Trek episodes will be on there. I just put out another one, a number 7 episode. Also, you're going to get emojis on there that you can use in the live chats. They're pretty cool. And as we grow our membership, I'll be able to put more emojis out there. Just a fun way to liven up the chat a little bit. Don't forget to like, share, subscribe, and comment, and have yourself a great day.